Okay. So Earth observation data and geospatial information collected and generated from space and in situ sensors is an enormous amount of data that is creating both great opportunities but also challenges for who wants to exploit it. So ONDA is the CERCO-DS solution that is enabling users to concentrate less on infrastructures and more on data, information, and analysis that are the core of their business. So ONDA is basically two things. It's a one-stop place to access and host geospatial data, and is a cloud-based platform to exploit it and build applications. And ONDA is supporting users at various levels of expertise that are exploiting geospatial data and information for diverse purposes. So this is the ONDA consortium led by CERCO Italia. OVH is our European cloud provider. GAL System developed an advanced data access technology called the Elastic Node Server, and Synergize provides the view service. So ONDA proactively supports the GEO mandate and vision by enabling the GEO community to create solutions for solutions to global challenges. How we do it? By offering free, open, and advanced access to your data and geospatial information, together with co-located computing resources. So the solution is data user and application agnostic. It means that the structure can receive any data type, is intended for users at various levels of expertise, regardless the thematic applications and the businesses they are dealing with. So one of our main goals is to foster the market by bringing together intermediate users and end users on a global scale, because this is, in our opinion, the key to fill the gaps and create innovative solutions to, of course, global challenges. For example, last 2nd of April, we gave voice to 3 of our intermediate users during the Copernicus Data Access Workshop in Brussels, organized by DG GROW. Of course, they explained why they choose ONDA, how they are using ONDA, but they explained also how they are delivering a solutions to end users that don't know anything about Earth observation and that didn't even know that there was a solution coming from the space and that is affordable. Among the initiatives that ONDA supports, there are, of course, the EuroGeos projects, with the main goal, of course, to create solutions for the Sustainable Development Goals. But at the same time, we always try to maximize the commercial potential of those pilots. And we are offering capacity building support because we are giving the chance to many solutions to come alive and become operational. Right.
So I just remind you that Slido applications should work as well. For those who are not there on previous day, I think the Slido application is with the hashtag GEO, and then choosing the session, which is session 9.
Okay, thank you. So these are key benefits coming from our users, either from our survey campaigns or from direct engagements. So the platform is open, so it's built in a way to avoid the lock-in vendor solutions. So we guarantee the portability of applications built on ONDA. In the same way, there have been also applications migrated from other systems into ONDA with very low level effort. So it's simple for the users. So just few clicks to access data services and especially predict costs. Flexible in terms of solutions, but also in terms of payment methods with our pay-per-use plan, monthly subscriptions, dedicated billing, and discounts on long-term agreements. So it's reliable. Onda is already proved in large processing scenarios. The most recent one I can tell you is the Sentinel-3 Wildfires Atlas prototype, developed and published a couple of days ago by the European Space Agency. You can find more details also on the website. So secure, compliant with international standards and regulations, and fast to market thanks to our competitive prices. So for the same price proposed by our cloud provider, we are giving our users access to the data and additional services to exploit it. So these are some numbers coming from the public dashboard you can find on the website. In less than 1 year of operation, we reached more than 15 millions of products, and we are talking about almost 16 petabytes of products, of data. We have more than 600 registered users, and this month we have more than 155 active virtual machines. So we are bringing people on data through one of the largest archive ever built for geospatial information. So our current offer consists of Sentinel-1, 2, 3, and the Sentinel-5P. We are going to ingest it in the coming days. Envisat, Landsat 8, and the Copernicus core services. And more data is about to come, so we publish all the details in our website or in our newsletters. This is online data, so it means that it is immediately available to our users. Once the data is published in the corresponding hubs, we are committed to make it available into Onda without other delay than the transfer time. So we're talking about a complete archive from June 2016, and we are also building the long-term archive before this date. And it is a growing archive, so we keep on ingesting data without removing the previous one. It's data agnostic, so the users can ingest any data type they want, and we are also going to include the in situ data. So there is a list of candidate data sets that we are going to ingest on the website. And we also offer a third-party data hosting service. So this is an end-to-end service from the migration to the dissemination of the data with the data access rights and privileges defined by the users. So together with the data, we offer co-located cloud resources, so tailored virtual service for any scenario, from entry-level machine to high-performance infrastructure. So we have pre-configured templates you can find in our website. So you can choose the model that best fits your needs and create it and start working on it without the need to engage with our teams. You will be able to upgrade or scale down at any time to install any tool that you want. We also have pre-configured templates with some open source tools already installed. There is a non-exhaustive list on the website. So you will have direct access to the data, guaranteed security, performance, and again, flexible solutions and methods. So we want our solution to be useful for the entire Earth observation value chain. So from the upstream to the downstream, from the data providers to the end users. So this is why we offer 3 working environments. So the command line, that is standard way to access the infrastructure for more advanced users. The remote desktop with the aim to facilitate the access to the infrastructure. And the web application is a tool for our intermediate users to showcase or deliver a product or a solution to their end users. So as I said, the systems is built in a way that enables our users to go to our website to define, to choose the model that best fits their needs and start working on it without engaging with our teams. However, we always put our technical expertise at the disposal of the users through a first line of support, including service desk, online documentation, newsletter, and other web content. And as an option, if you need higher level support, we also offer professional services. So our cloud architects can help you creating, migrating, operating, and managing your system, your solution. We can also put in place any service level agreement that you want, even for already mature commercial services. And again, we also offer a third-party data hosting service. So Onda also offers a marketplace that is a showroom in the GEO community in order to foster the market and trigger relationships. So this is both a promotional area for the users to promote their services, but also a market for the GEO community to find, access, and maybe subscribe for a service. And we invite you to visit it because we always update it with new services. There will be at least two, three new ones coming in the following weeks. So these are some users and projects running on Onda. I would like to highlight the heterogeneity of the users. So we are supporting individuals, students, universities, research centers, startups, small and medium enterprises, large enterprises, space enterprises. So it's a solution that is supporting users at various levels of expertise, regardless the thematic application they are dealing with. Among our initiatives is, of course, worth mentioning our free trial access program. So we want to raise the confidence on Onda. The best way to do it is let our users try it. So we give free access to our virtual machines for our users to test them, maybe to migrate their applications. And we are proud to say that many of them have started with this program, and after that they have decided to keep on relying permanently on Onda. Another interesting initiative is Onda for Education. So this will be a commercial service for thematic training on Earth observation applications through public webinars, but also through dedicated webinars for specific needs. So this is intended for universities, but also for anyone who needs it. So these are some conferences where you will find Onda, of course, Living Planet Symposium, Free Week, UK Space Conference, etc. Onda is also happy to support many initiatives by giving free access to the virtual machines and support during the events, and also participating to the prizes for the winners. So these are some active evolution lines. So extend the Onda portfolio. We always extend our portfolio by ingesting new data. We are going to ingest also in situ data. And we have also started discussions with commercial data providers to extend our portfolio. There will be in the next weeks also a planned acquisition view tool for the users to see the planned acquisitions of the sensors included in the offer. Onda for Education, I already mentioned, and we are going to share more details. And additional cloud features, so we always reflect the cloud innovations coming from our cloud provider immediately into Onda. And then there are Onda GS web apps for our intermediate users to showcase on or deliver a solution. So please, for further information, visit the website, also subscribe our newsletter, follow us in the social media, and please feel free to contact us, to contact me, to tell us your requirements and to find out how Onda can help you. So with that, thank you very much and have a nice day.
Thank you very much, Mario. As usual, the question will come at the end, and immediately I give the floor to Wendy from SoBlue.
Thank you very much, Danielle. Good morning, everybody. So I'm going to start talking about the Copernicus DS SoBlue, which is led by Airbus with the support of Capgemini and Orange. Before delving into the details of my presentation, what I would like to recall is other words from Gunther Landgraf in his presentation yesterday around the digital platform economy. And in a presentation I made a couple of weeks back at the UN, but this time in New York, the emphasis I put in mentioning the digital economy was on the fact that we are seeing a whole new series of public-private partnerships around the developments of these platforms. And if I may, the DIAS, at least the way we conceive them on the Airbus side, are typically these new forms of digital platforms that are built together, I would say, with public funding, with private investments, with, I would say, a goal in the long run to make sure that data is available, but more importantly, that value can be derived from data, because accessing data should be the easy part, and it's all the innovation and the creation and the growth that it generates and the applications that it has in the context of the SDGs or in a broader context that matters the most. So without further ado, I'll go directly into the presentation of SoBlue. The idea, as I was mentioning, is really about accessing the data to start creating. So from that perspective, it's having access to different sources of data. So I'll go into the details of what we have in the Copernicus Sentinel world, but it's about promoting access to multiple data sources. And on our side, we give access to Copernicus Sentinel, to Copernicus Core Services, but also to Spot 6, Spot 7, and Pleiad, very high resolution data, as well as FluxVision, mobile and geolocation data. And we're looking into more, I would say, aerial and drone-based data that we are collecting, not necessarily from ourselves as organizations, but from the third parties that we are engaging with. So for us, it's really this multi-source data access, which doesn't mean that all the data will be stored directly on SoBlue, but it will be easily accessible. And one word that was used quite a lot yesterday, I would emphasize, is the need for metadata. Because I come from the world of open data, and in the world of open data, you can have the best data catalog, but if it's not indexed and if the metadata is not correct, it's going to be very difficult to discover, and it's going to be very difficult to make use of it. So from that data-related topic, there's also the processing. So we heard a lot yesterday about cloud and how cloud is changing the way we are working with data and offering new capabilities, building also on high-performance computing, which is also one of the initiatives of the European Commission that we're trying to look into to leverage, to connect the dots in terms of the different investments that are being made. It's also about tailoring, to say, well, we can have the best platform and consider that it's very good from our own perspective, but it's not a one-size-fits-all. It's really to be from a pay-per-use model for the cloud, but also from a marketplace approach in terms of helping people find what they need, and not sort of saying, here's the data, we're shoving it down your throat, make use of it, and some magic will happen. No, everything is tailored, and the professional services that we offer are unique to each of our different third parties that we're engaging with. It's also an Earth observation toolbox, because I remember a comment that Gilberto Camara made, but I don't think he's in the room this morning, was the fact that, well, this is all useless. Oh, you're over there, Gilberto. Is the fact that, well, if you don't have the right developers environment, what you're doing is useless. And Gilberto knows that I'm not a technical person or an engineer, but on the SoBlue side, we have put a lot of our emphasis in the development of what we believe is useful for people to actually process and make use of the data in the big data context that we are now in. Also, back-end services, that can go from managed services to help people with the cloud, to also make it easy, because the motto that we have is really for people to focus on what they do best. And what we want them to do best is the development of useful applications that contribute to the value, which I believe is also part of the GEO mandate today. And it's this idea also of having a universal docking station. As I said, everything is tailored, and it should be plug and play. So it should be made easy for those connecting to it and who want to make use of it. So we use OGC standards. We're also in discussions with OGC to help advance the standards, because it's good to complain about standards, but there are also things that can be done to move them forward. So that's also discussions that we have started actually mid-April that we want to contribute to make sure that what we're developing will also be future-proof. I won't go into the details of all the managed services that we offer around the cloud. The presentation will be made publicly available, but the idea is really to leverage via the cloud all the compute benefits that we have in terms of different flavors of virtual machines, but also all the add-on services in terms of data analysis, application services, network storage, database management, to make sure that this world of big data is really available at your fingertips on the cloud that you can access via SOAPLU. And all of this is powered by Orange, our cloud provider, and they have experience in this, so we're not actually reinventing the wheel by trying to position ourselves as experts in the cloud. We have a full suite of expertise which is recognized internationally in this respect. Going beyond the APIs I was mentioning a bit earlier, it's really, and this is dear to our heart, and I really want to underline that part, is to make sure that what we have is useful for developers so that they can hit the ground running and have access to toolboxes and services, ready-to-use services. They have the analysis-ready data on the platform. They can contribute their own data to it. So we have been focusing a lot on developing open-source container orchestration solutions such as Kubernetes, where a lot of the feedback of the third parties we are getting is very positive in terms of the ease of use and the different auto-scaling features that we have. So this is feedback that we're very happy to share because it was I would say it was a bet we made on taking this approach, knowing that we'd probably be subject to criticism, but for us, all of the users have been making use of it and are very highly satisfied with what they're experimenting with on SOAPLU. Also, we have made available access to over 180 macro services that developers are fond of and are using. And we're not simply doing this because we think these services are the best. We're interacting with the community. We're leveraging the expertise within our consortium to see what is it that should be best made available and what is it that should be open as well, so that anybody who wants to bring their preferred environment over or their preferred tools can do so. So it's in that spirit that we developed the SOAPLU desktop. And the idea of this is really to facilitate everybody's daily work, to make sure that they have, as if it were their own desktop, their way to manage their console, to manage their services, to manage their developers' environment with the tools that they seem most fit. Also, SOAPLU SDK, which guarantees easier access to the different APIs that we have. We've also been developing together with a few of our users a SOAPLU GitLab repository. And in there we have Docker files, scripts, source code. We're also leveraging user feedback to add more, to encourage them to share in this, to really contribute to the ecosystem and to make sure that the ecosystem actually contributes back to those who could leverage and, I would say, expand and extend the different solutions. So it's, I would say, an adopt and adapt approach, but also an approach by which we expect to receive feedback. So our GitLab is entirely public, and we are encouraging others to share their source code as well in this GitLab as they make use of SOAPLU. I was mentioning the ecosystem, so we have a strong footprint in the European ecosystem where we are supporting entrepreneurship and innovation. So we're part of the many different European initiatives, as you might have been hearing for the past 2 days. The DIAS are not unique, and we do not consider ourselves as being the sole owner of this ecosystem. We see ourselves as having an important role. Also, I would say from the Airbus side, we have been having a very strong presence for the past 30 years in this or more in this field to make sure that we also contribute to nurturing this ecosystem. So we have an Airbus-specific challenge on multi-source data access under the Copernicus Masters. We're also engaged in the Copernicus Accelerators. So a bit of jargon busting for the Copernicus Accelerators. These are 50 startups that are incubated by the European Commission DG GROW, who have innovative ideas and concepts in the field of Earth observation, who are invited to make use of the Copernicus DIASs, not simply of the infrastructure, but also of all the support services we can offer. So for instance, we're interacting with a number of them. It's not so much to use the cloud or the data, it's to help them develop a business model, for instance, or to help them develop the marketing and the approach that goes well for them to go convince other organizations to receive additional seed funding and such. The Copernicus Hackathons, so those are hackathons organized by DG GROW as well across Europe. And we have provided in the past 3 months over 100 virtual machines for these hackathons. Why do we do that? Well, because we want to abide by our motto, which is to basically support this ecosystem and support innovation and growth. Equally, we have multiple commitments in 2019 And we're supporting a hackathon in a couple weeks' time in Barcelona on the smart cities topic. So typically on Friday, we're giving a webinar where we're going into the details of how Earth observation can be used in the context of smart cities, and how other sources of data can be used to combine with Earth observation. SoBlue is everywhere. I mentioned the European ecosystem because I would say that is our starting point, where our roots are. But we are also in contact with a number of organizations in South Africa, with Africa GEOS as well. We have a several number of early adopters that are from Japan, where we're interacting with similar DIAS-like initiatives in Japan for the past 6 months, and also helping, I would say, the Asian market understand a bit better this initiative. We have a lot of contacts also in China, in understanding how big data processing can be used to leverage Earth observation data. And in February, we were also presenting and introducing the DIAS concept in the Emirates in the context of the World Government Forum. A few key facts and figures, so I won't go into the details, but it's just to give you flavor that this is not just a promotional pitch. It's actually underpinned by real data, real storage. So it's roughly 17 million Copernicus Sentinel products. So it's the full Sentinel-1, Sentinel-2, Sentinel-3, and 5P. In local storage, we have all the core Copernicus services, with the exception of the climate data store, which we will only be having in June. So all of this is local. So that means you can run processing on the fly. And maybe to preempt a question that we were debating yesterday at lunch, how is it that we work and how is it that we guarantee an SLA? As SoBlue, I don't want to speak on behalf of the other DIASs, but we harvest the data from the Sentinel DUS. And from there, we actually have it in local storage on SoBlue to enable processing on the fly. So we are dependent on the data being made available by ESA. And at the same time, what we do to make sure that the data is fresh, we ping the DUS every 10 seconds to check if there is new data available. And then we bring that into local storage. Often also questions that we have are around Landsat data. So we make it available on demand. And the integration of the Spot 6, Spot 7, and Pleiad high-resolution catalog will be completely visible and seamless for users as of mid-May. We have a demonstration about that during the Living Planet Symposium in 3 weeks' time. And today we make it available on demand. In terms of third parties that we're working with, so it's not simply, I would say, partners within our consortium who are making use of the platform. It's startups that are on the complete outer borders of the Earth observation ecosystem who come up to us and say, we have an idea, and we were watching a few videos on YouTube, and we understood that satellite imagery might be something we could leverage. So this is something that I believe is particularly new and particularly relevant in the context of the GEO mandate, which is the evangelization and the value definitely comes from the community, but it also comes from expanding that community. And part of what we are spending a lot of time doing in our domain is working with companies such as DigiNov or others who are trying to understand what is it that they can gain from satellite imagery. So it's that extra mile that we believe will take time to leverage and will take time to prove, but means that what we're doing with these platforms makes sense, and it makes sense to those who are not so familiar with what we do. So I'm almost out of time. The idea, again, is really for users to focus on what they do best, and whatever the application domain, we're not restricting any particular thematic area. We're not restricting any type of data. When people come to us and say, we would like to put data available in your catalog, we define the roadmap, we define the technical requirements with them, we define what type of users they want to serve, and we really do it together with the users to make sure that their key benefits lie where their business value is or their institutional value is, and it's not their problem to understand our platform or how we work. What's in it for GEO, just in the 1 minute I have left? It's Copernicus data, of course, because that's the core mandate of the Copernicus DIAS, but in the context of SoBlue, it's so much more. I mentioned a lot of high-resolution data, but we also have the processing chains of the French Space Agency CNES. So we're processing on-demand level 2A and level 3A products such as auto-rectification, also cloud coverage, also aspects such as snow on and snow off, which we're doing, and we're processing that directly based on Sentinel data, which is stored on the SoBlue cloud. It's this full developer's environment to make sure that it's not, here's easy access to data, okay, fine, what can I do with it from now? So it's that developer's environment with all the big data tools. It's expertise at your fingertips, and it's not just cloud, and it's not just data, it's business modeling, it's marketing, it's all those add-ons that take a lot of time to smaller players in the ecosystem to leverage, which is that next step that they need to come up with solutions that are fit for the business and the digital world. That's the end, and the final part is the marketplace, to say it's also about offering an opportunity to others to promote their solutions and to promote their approach and applications. So contact details, you can find more information on the website. Feel free to get in touch. We also have a free trial exercise, and I'm out of time. So thank you very much for your attention.
Thank you very much, Wendy. And now I pass the floor to Alec for CREODIAS.
Hello, everyone. I feel a bit intimidated after two great speakers. Unfortunately, I'm an engineer, so I'm not used to speaking in front of big forums. So I'll not repeat things about what is DS and why we do it. I will try to concentrate on the things we think we do in some specific way. I will try to go a bit into the technical details, but not too deep. So some of you might remember this picture from yesterday's presentations. Yes, this is not CREODIAS. It's another cloud that we have built, located in Reading, UK. The CREODIAS is a consortium of a group of specialists in the GEO area, but the companies that led the project are Creotech, which is the Polish company specializing in building stuff. I mean, the manufacturing real equipment that goes into space, and Cloudflare, who is a cloud computing company. So Cloudflare specializes in building clouds, public clouds, private clouds. The other companies are Geomatis, Eversys, Synergize, and VisiPC, which is a company specializing in semantic data search. The CREODIAS is not the first platform we built for the purpose of the Earth observation industry. A few years before, we started with the EOIPT Poland project. Some of you might have heard about or even used, which was a pilot project to prove the concept of the DS as a self-sustaining cloud environment for the EO. But the concept proved working. It was a success, and this is how the DS began. So our experience with building clouds for EO goes already for 5 years or so. So this is CREODIAS. As you can see, it is much bigger because it has to accommodate currently more than 30 petabytes of raw bit data, which translates into roughly 15 petabytes of usable data. So when we look at the community of the CREODIAS users, we see two main purposes of doing that. First is the development of tools, applications, software, processing of data, and second, which is as much as important as the first one, is the storage and distribution of the Earth observation product, both satellite products and in situ data. So as the infrastructure specialists, we concentrate a lot and we put a lot of effort to make the second part, the management of data, in core of our infrastructure. So the CREODIAS is the repository. It's a big set of tools that manage the repository, that keep the data coming into the repository and being properly distributed. Set of tools that enable users to access, search, view the data, and a cloud infrastructure that allows processing of the data. As I see the market currently, there are a lot of specialist engineers that know how to deal with virtual machines, the cloud environment. So it is quite easy to set up an environment, and the tools are quite comparable. The VMs are everywhere pretty similar, not exactly. I will tell more about it later. The storages, the interfaces to interact with the clouds are pretty much standard. But how to manage the EO data, it's not a trivial thing. There were many things said about the management of the metadata, the validation, the quality of the data, the timeliness of delivery of the data. This is something that is very specific to the Earth observation, as you perfectly know. So when we started dealing with Earth observation information, we concentrated on building a very robust and reliable data acquisition system. Because somebody said yesterday that if we combine all the different sources of the satellite products, we end up with several hundreds of petabytes of information. So even if we copy most of it locally, that doesn't mean that we have everything, but the users would like to see everything, to have access to everything. So we have created a system that is able to get the information, the products, from any possible source, being it Copernicus hubs, being it EUMETSAT sources, Mercator FTP servers, or any other kind of storage or distribution point, get the metadata, get the information about the product, analyze it, index it, store it, and show it to the users. We, of course, get the data that we decide to keep locally for the users to use, mostly the Copernicus data. But we also enable the users to order the data they want to see. The data that is not often used, sometimes for the very specific needs, but they can get it in an automated way through the API, through the dedicated user interface. What is more, there are new algorithms coming, new products, especially higher level products coming. We cannot think about all the possible things that people want to do with the data, like the recent projects requiring Copernicus analysis ready data, so the process Sentinel-1 or Sentinel-2 products with some specific algorithms. So we have built in a functionality that using the same tools, the same machinery, the same APIs, users can order products generated on demand. For example, Sentinel-1 6-day coherence products or backscattering products through 2015. They are not available anywhere, but the users can just order processing of any Sentinel-1 product into a hard coherence product. Additionally, customers have their own collections. Some of them are private, can be stored in a private storage on the cloud. That's the easy part. But some of them want to share what the data they have. So we have also created a mechanism that allows them to define how the metadata of their own data maps into our database, and we can set up an automated process to get the data for the customer and distribute it in the same way as all the other information. The ingestion system, of course, validates the data, controls if it's up to date, controls if it's fine, detects all the strange errors like geometry errors in Copernicus products, which unfortunately happen from time to time. So the data you have in the repository, which is the final location, is validated, checked, and ready to use. But the repository itself is just data. You have to have access to a way to access the data. Most popular way of accessing data is just reading the files. So our repository is built in a way that you can access it through typical file access protocol, NFS, or object access interface compatible with Amazon AWS. This allows portability. Anything built on any cloud using S3 can be easily ported to our infrastructure. Other interfaces users may use are the WMS service provided by Sentinel Hub, which everybody well knows. I said about the ordering part in the acquisition engine. Okay, let's assume the user orders hundreds of products that are not in the repository, the very old one or very specific ones. Where do they land? They land in a cache, which is 1 petabyte, so it can store a lot of. It store a lot of products, and all the other users immediately see that product. So, for example, we have some environmental emergency situation somewhere in the world, and somebody orders all possible data for that location, and any other user coming to our platform looking for the same data will find it already locally stored. Information about the data we have. It is in the presentation. The bottom line is we have probably the longest archive of Sentinel-1 data and Sentinel-2 data on the market, because we started. We have the full collection of those products. We even store Sentinel-1 level 0 data. One information about Landsat 8, because we used to say that we have the complete collection of Landsat 8 data for Europe, but unfortunately ESA stopped distribution of Landsat 8 data beginning this year. So we will switch to getting that data from USGS, but it will be available again. We waited for ESA to come back with the distribution, but it didn't happen. Okay. The data is there, metadata is there, catalog. Having an ability to search the data is a very important part. So we provide interfaces like open search interface, because the metadata is stored in the RESTO database. I think Brian said something about RESTO yesterday, telling that the CEOs put RESTO on the list of open source tools recommended. So open search interface, SparkQL for semantic search, OGC CSW interface, so you can query SparkQL, you can query Inspire compliant queries, and what is the most important, open search API. The cloud services. I will not repeat what has been said. Virtual machines, storage, networking. We made the service so we can copy any environment you would like to design at home, on premise, into the cloud. The differentiator we have created, because we see a lot of efforts in machine learning area and artificial intelligence. So we have added a special service with dedicated GPUs, so virtual machines with dedicated access to NVIDIA GPUs, to help you develop the machine learning services faster. QRDS, of course, needs to be a bit user-friendly, because it's not all about infrastructure, virtual machines, repository. So we created a set of tools. The most important one, from my perspective as engineers, is the EO Finder, which is the UI to the open search interface. It is very useful for people that begin interacting with the repository and the data, because it can work as a creator of the API queries. So whatever you define as your query parameters in the UI can go directly into an API query without reading the documentation about it. So to summarize, this environment is open and flexible. Open means it's open to everyone. We have approximately 1,500 registered users on the platform, approximately 1,000 virtual machines in our clouds combined. So every user can access the information at any point. The data is ready. The data is available from any service or any virtual machine, any interface. We comply with industry standards. The users are free to use any environment they want. They need Linux, they can use Windows, whatever. And we support very specific configuration, integration with external data, and very fast deployment. We've seen users coming with their ideas, setting up the environments in minutes, telling us just that they are ready to process, asking few questions, and the algorithms were running. In part of the application development, We have tried to replicate the development chain for most of the application development. So we have created the Jupyter notebook-based hub. We allow people to test using the free credits. We help people to develop scalable Kubernetes-based applications, and we help them to integrate everything in a production environment. Some of the projects, we have small projects like Rescue, but very big ones like Sen4Cap. There was a question about integration with European Open Science Cloud. So in our pre-production environment, we have federated identity with EGI single sign-on. And we are working on a few details, so you will see it available on the login page of CryoDias. If you have EGI credentials, you will be able to use CryoDias as a standard CryoDias user. So please take a look at the tools we offer. I am sorry that I was not talking much about business, but mostly about technical stuff. So if you have any questions, catch us later. Here's Maciek, who is more sales and marketing oriented than me. Thank you.
Thank you very much, Oleg. And now I pass the floor to Stefan, speaking for Mundi.
Thank you. So good morning, everybody. Thanks for giving me the opportunity to introduce Mundi to you. So rather than giving you a very technical presentation on the capabilities of Mundi itself, I want to give you a report, let's say a testimonial from real-world usage. So the really challenging processing on the Mundi platform. Okay, said this, let me have two brief slides on the capabilities of Mundi as a platform itself. So as all the other DSS, we have petabytes of data online. We have DLR, the long-term archive from DLR for the full archive of data. All the Sentinels as well, non-Copernicus data. We are relying, so Mundi is relying on the Open Telecom Cloud from T-Systems. So this means, as you can read the numbers, 2,500 servers and so on and forth. We provide also advanced tools. So Jupyter notebooks have been mentioned and others. What we also do is we are trying to enrich the data formats. So we are cloud-optimized geotiffs. That's the buzzword these days. So, for example, we find Sentinel-1 data is cloud-optimized geotiffs on the Mundi platform. In terms of users, we have currently 750 plus users. It's increasing. And we have also some customer projects, 3 to 4 new projects every month on the Mundi platform. So the consortium of Mundi, as I said already, the foundation is on the T-Systems infrastructure, so the Open Telecom Cloud. We have DLR for the long-term archive. We have Thales building the catalog service. We have GAF, EGEO, Spacmetrics, Synergize, and UX as suppliers. And the whole consortium is managed by our coordinator, Athos, in France. So let me jump into the examples that I want to demonstrate today. So from the technical aspects, the basics, as I said already, we have the cloud environment, Open Telecom Cloud. It's based on OpenStack, so it's the same architecture as other clouds as well. You can access it there. You have the standard, we call it ECS, Elastic Cloud Servers, so virtual machines. We have object storage. You have the typical network configurations for input, output, classical tools on the dashboard as the OpenStack provides it. Also, I want to mention that the Open Telecom Cloud is based in Germany. So for some, this in terms of PPTR, the data rights, this is an important aspect. So what you get on the cloud is what we call a tenant, and then you have the typical cloud environment where you can build monthly on your usage, and as in any cloud. So what, in terms of the data, what does the cloud provide? We have a catalog web GUI graphical user interface. So if you come to the website, that's powered by Synergize, again, Synergize viewing services and also UX viewing services. And we also have to build the implementers of this user interface. We have the also, as mentioned already, open search, catalog search for the web endpoints. Standards, SOGC, so standards are important in my opinion. So now to the example, what are we doing on the cloud? So we have a Python stack. We have built a software that's called Metadata that we are using to process data. It's a tiling, so we call it a tile processing engine for raster and vector tiles. So we directly connect to the provided services, being it on Amazon, Creatives, or Mundi, catalog, object storage, and it's kind of a data cube infrastructure that there we can run any processing, it's the framework for the tile-based parallelization, and then you come with your own Python code that does the actual processing, like selection of pixel values, for example. You have integrated for Sentinel-1 processing the ESA Snap toolbox, and even re-implemented a couple of functions for performance reasons. And on the viewing side, in the end, if you have the final output data, of course, it's stored in object storage. But now one new thing that we are working on is using GeoTIFF.js so that we really can view the cloud-optimized GeoTIFFs in the browser. So it's, as Amazon coined it, it's even less serverless than serverless. So this is one concrete example that we have been processing on Mundi. It's Sentinel. So this just gives you the area of our processing and an idea of the parallelization that we have done with Metadata. In the end, it's a Sentinel-1 processing of 14 days map on Gamma Knot, whole year of 2018 down to full resolution 10 meters. So these are the details. Bi-weekly statistics, Sentinel-1. So I'm not the radar expert, but we have seven bands of this data. So we have the VV and VH, and we do the statistics over these 14 days, average, minimum, maximum standard deviation, and count. And then, of course, we have also a nice preview, as you have seen in the previous slide. And all this data we have made available as public data with a CC BY non-commercial share-like license. So just a word of warning, if you follow this link that I have here, your browser will download quite some megabytes of data. It's still megabytes, but here on a roaming plan, just that you know it. And I also put the URL, how you can access the data to construct the actual GIFs, if you're interested. We are working also on Coherence Mosaics, so Belgium will be the first one to provide. Another example, an interesting example in my opinion, is so this is for being an Austrian company. We have Austrian customers, and we process the Sentinel-2 mosaic for Austria, and we have a very weird projection, or actually it's 3 in Austria, so it's for the eastern part, so that's why the area of interest looks a little distorted. But here you see an example of this. It's July, and you can nicely see how this evolves over time. So this is what we call level 3 data. So we go up, and the idea is, so that the point is that you don't do your processing on individual scenes anymore, but you use mosaics. You can do this for bigger areas, so like whole of Austria, whole of Europe, for example, or globally, as I will show in my last example. So this Austria particularly is done on Sentinel-2 level 2A. So we store on Mundi the send to core processed level 2A data. In this case, we are using a custom projection, the code from Austria. It's a monthly mosaic, so what you see in the animated GIF is just the NDVI visualization of this monthly mosaic for a small area, but it's available for the area the area of interest as shown before. Interesting to mention is in this case we have a single pixel selection method, so we don't make any averaging or combination of pixels, so that you can trace back the original metadata. So for each individual pixel, you can have a look from which original acquisition from Sentinel-2 this originates. And the selection is simply based on the maximum NDVI, so it's not rocket science, but it's a big number crunching you can do on the cloud easily. So coming to my last example, as I said already, we can do this globally as well. In this case, we have been using Sentinel-2 level 1C data. We have processed it in simple lat-long projection, but it's also available as WebMercator. And we can, in this case, we have used the weighted average method because we wanted to have something which is more visually appealing. You can have a look at these links to show it, to view it. And this is how it looks like from a global scale, but you can zoom in on any place on the Earth to the 10 meters, and it's there. And again, the visualization is openly available under CC BY non-commercial license. Happy to talk to you if you need it commercially. So in conclusion, what I hope that could show you is that that it's easy to work on the cloud with the remote sensing data. We have all the tools available that are needed, and as the speakers before me presented as well. We have even an analysis ready, or Copernicus analysis ready data, as we call it, available for Sentinel-1 and Sentinel-2 on Mundi. Right now, it's a focus on agriculture applications there for the analysis ready data. So for ERAX, our plans for the processing, our next plans is we'll produce monthly or weekly mosaics for bigger areas, Austria, Belgium, Lithuania, and the next maybe we do all of Europe if there is interest. Yeah, feel free to explore Cloudless EXAD as a Mundi service. And on the global scale, we want to make an even cloud lesser, I'm not sure if that's an English word, but a cloud lesser mosaic of the world with the new 2019 data. And finally, let me use the opportunity also to now taking my head as OGC co-chair of the Web Coverage Service Working Group on to invite you to, as Günther mentioned yesterday, OGC is working on a new evolution of the standards, adopting Open API. And end of June, 21st of June, we have a hackathon in London. So if you have an implementation of any OGC service, please join us at this hackathon and help shaping the new version of OGC services. Thank you.
Thank you very much, Stefan. And now for GEO, Laia, please.
Okay, thank you, Daniel. So my name is Laia Romero from Mercator Ocean and Michelle Schick from UMETSAT. Baudouin from ECMWF is also here. We are the three implementing partners for WeGeo, and we will explain you a bit what this particular DS is offering, how we work, how it is implemented, and the roadmap for this activity and how we can work together. So, okay. What is WeGeo? In very short, we offer data. The data is there. Our colleagues have been going through it, Copernicus data and information. We offer virtual environments. We offer tools, specific tools, and we also offer user support. This is implemented by Copernicus partners, and the user support approach is very much based on the Copernicus approach, with training, user workshops, and so on and so forth. So this is the first thing you will notice from this DS. WeGeo serves all users, public and commercial. And this is important because I get this question a lot. For the data, at the moment we have Sentinel-1, Sentinel-2, and Sentinel-3, and as you will see, because one of the consortiums that are joining WCAO includes Cloudflare. We will be also including Sentinel-5P in the future. We have CMEMS, CAMS, C3S, CLMS, and in the future, the emergency services. On infrastructure, we offer t-shirt size projects from extra small to large and bespoke, covering CPU, also GPU, storage, public IPs. So you can find all this information online, and I didn't want to be super specific on these characteristics. For the tools, the VMs are pre-configured according to a comprehensive survey amongst the communities. So you have climate, ocean, different pre-configured images for specific uses that we hope that will be useful for you, and also the platform services. WCAO is a distributed infrastructure, and this is the first different aspect from the different DSs. So we keep the data at the source. This means that beyond the 3 partners, we are open to new players, to new stakeholders that hold their own data, such as EODC, that has already been federated into WCAO this year, and we can access their data, and we can also host projects on their premises, on their host, on their cloud. Sorry. And the offer is simple. We have an essential offer, an advanced offer, and the federated offer. For the essential offer, which is free, you can access the data, view it, download it, access the user support, which is, as I said, very strong. And also you can access the Jupyter Hub and do limited processing from there, test it, subset, etc., with the harmonized data access tool that we offer. For the advanced offer, this will be pay-per-use in the future, and right now you have a 6-month trial period. You can join the advanced offer and get access to hosted processing, to virtual machines, also until October this year. The federated offer is bespoke, so come up to us and let's talk. If you have data available from a collaborative ground segment to agencies to public institutions or big companies that have a lot of archive data, you can get federated and be part of WCAO as well. This is the federated offer, so you can share, be labeled, and access a lot more users. At the moment, we have already more than 700 registered users and up to 100 projects ongoing from pilot users. The strengths of these DIAs in front of the other DIAs that were presented, and we included this slide as this was one of the recurrent questions this week. Beyond the experience and the skills of the partners, we offer a unique harmonized data access for satellite data and also for services. So from the same API from Jupyter or from the virtual machine, you can access all the data and benefit from the subsetting and any specific conditions that are applied to this data, subsetting in terms of variables or depths or to all of the data from this harmonized data access. The data harvesting is minimal because we keep the data at the source, so we are not replicating the entire archive, but we aim to bring together all European players to share their data and make the most out of this so that we can have the largest archive possible and accessible in a very easy way. The Copernicus partners offer Copernicus information, and so this data is up to date. So if you're working on a project that uses ERA 5, you will be hosted very close to ERA 5, and there will be no other place where you can find most up-to-date data in that sense. Also, as I said, the virtual machines are thematic according to the needs of the communities, of the different communities. and we capitalize from the user feedback. These up to 100 projects that we are hosting during the pilot time, this timeline up to October, it is in exchange for user feedback. So we are co-designing the project with you. The implementation, this is also different in GEO, and I wanted to highlight this point. We wanted to highlight this point. So there are three main areas in GEO. One is the user management. That includes the validation of the service, the monitoring of the overall service activity, the user support, the web portal, and user interfaces, and also the marketing and communication activities. This is led by Mercator Ocean, which is the trusted entity for the Marine Copernicus for Siemens. The processing and the tools that include the catalog, so the data access, the tools, and also the processing. This is led by ECMWF, that you already know, and the infrastructure that covers elasticity, all the interfaces, the computing, storage, the network, and the overall system integration and verification. This is led by UMETSAT. And each of us, through procurements, we're bringing together industry players that are making the most out of this design. So for the user management, we have 4 ITTs. The first one is closing on the 29th of April, and it is the ITT for the web portal. You can find it in UMITS at UMETSAT site. Then coming up very soon, there will be a user support ITT, a platform monitoring ITT, and a marketing support ITT. And we encourage all of you to participate and to submit your offers. Then for the data access and tools, the ITT was already closed and the contract was awarded to GMV. GMV is the prime, but it's also Be Open, Server Labs, MEO, Synergize in the consortium, and they're working on delivering these tools and pre-configured images for what we call V1. And the infrastructure ITT that is led by UMETSAT, and that was awarded to Thales and Cloudflare. And the kickoff was just recently took place last week in Toulouse. So the roadmap for this overall implementation is that we kicked off at Baveno in June. There we already had our first pilot users that were onboarded. We offered from day one the user support online and a V0 version of GEO. This V0 version was not perfect. It's getting more perfect by the day. We are working on it with our pilot users. In November, we had already an update release, the V0.1. We federated EODC, so that made our data offer stronger. And we opened the advanced offer 6-month trial to 100 seats, which is what we have today in place. Then during this time, from April until June, the list of advanced users is growing very quickly. They are already providing the first results. I will show you one on their activities. They're providing feedback. In June, we will have the price list from the ITT 1 consortium, from the Thales consortium, and we will launch the V0.2. And it will not be until October this year when we will have the operational V1 and the kickoff of the commercial activities. So this is for you to have a real sense, and I hope this is clarifying of what GEO is, where we are today, and where we are going. Then, Michel, if you want to make some...
Yes, I mean, we were thinking a little bit what is interesting for GEO in the sense for the DIAs. I mean, some of the points listed on here, they are applicable to all of the DIAs sitting here on the table. I mean, in principle, why should someone use the DIAs? I mean, in today's big data era with the huge amount of products, huge amount of data to be transferred, downloading all the data directly from the sources, and building up your own archives is not in the future any longer feasible, because you would need to have your own infrastructure. You would need to scale your bandwidth to store petabytes of data. If then at the sources, the satellite providers do reprocessing or updating through improved algorithms, the data itself, you have to re-download again petabytes of data. So therefore, the permanent downloading and building your own infrastructure with petabytes of data is not really a sort of desirable goal. So hence, having cloud computing infrastructure together with the data gives you very easy, quick start. So you don't have any data management headaches. You have ready-to-use data and infrastructure to generate information. The DSS platforms offer you the option to bring your own algorithm and quickly start exploring the data itself or setting something up. You don't have any upfront large investments on infrastructure itself. What concerns the data, you don't have to pay for that because it's been already funded by Copernicus, the data and the systems itself. All of the DIAs offer various subscription options, which you can cancel anytime. There are various support levels from training to engineering, where you can get even development support. I think the various DSs offer these kind of things, and people are immediately productive. Yeah.
So this is an example of one of our pilot users, Ocean Data Lab from Brest. They are accessing, as you can see here, the entire GEO catalog. So you can see here the Sentinel-1, the Sentinel-3, you can see some CMEMS data, and it cannot be seen very easily, but through the harmonized data access and the public API, they have put together their visualization system that is accessing the catalog in the backend. So what can we do to help you today? If you have a project, if you have a service that you want to move to the cloud, contact us at support@wikio.eu or through our website. You can check in our dataset navigator at wikio.eu the entire dataset catalog. You can also try the Jupyter Hub online, and you can apply for the advanced offer. You will get a six-month trial period to have your own t-shirt-sized virtual machine and run your project. And what we guarantee is a very smooth transition from now to V1 when commercial activities begin. We will be very happy to have you on board. So that's it from us.
Thank you very much for all those presentations. You see 5 dias, 5 different presentations, the way it has been done. Now for the question, what I propose is that I would go, Laia, if you can please switch off.
Oops.
Thanks, the mic. Thanks a lot. I will go immediately on the Slido questions. The first question is very technical. How many paying customers do DIAS already have? Is the user uptake good enough to achieve financial sustainability after the startup funding? I'll just start with a word on how this has been done. As you know, as I've been explaining, there are public funded tasks that has been asked to the DIAS, and then it was for the DIAS then to go and try to get as much customer as possible. And of course, we are on a early stage. That part of those development, as the DIAS are competing together, has been left to them as a confidential information that we could have access looking for the long term. We are now at the beginning of this exercise. Having said that, I'll leave the floor to each of the DIAS if they want to go into this discussion.
Okay, I will start. So We are working since the beginning to be self-sustainable. So what I can tell you is that today we exceeded the 10% of the total contract value in terms of additional revenues. And we are using those revenues for several initiatives that I showed in the presentation, including, of course, our free trial access program and other initiatives like the Copernicus Hackathon, etc., and also to reinforce our data offer. But we also have a promising prospect, so we will keep on doing our best to be self-sustainable.
So we'll go in the same order. It's the million-dollar question, I would say, and we often face it. Yes, we do have paying customers. It's relatively new because we had a lot of trial offers, as was described previously, in terms of the early partner program, which is still running. And we're happy to announce that part of those who are in the early partner program, usually roughly between 50 and 60% of those in that program, transform that into a paying contract. There are also some specific customers with whom we have such an extensive, I would say, investment in terms of the ecosystem that for them, we're still in the process of defining what's the best way for them to proceed. So we're still defining what type of financial construct we should be making. Typically, if I consider third parties who will be contributing very soon to our marketplace and to our algorithms, should they be paying the same as those who are simply consuming cloud and compute, for instance, as opposed to those who are contributing directly to the marketplace? In terms of sustainability, we at Airbus have a number of additional initiatives promoting value creation out of Earth observation data. So whether we keep the different initiatives that we have separate but interconnected, or whether we merge them in the medium to long-term future, that's, I would say, an Airbus-specific decision. But that is, to some extent, a guarantee of the financial sustainability and the overall sustainability beyond the end date of the contract that we have with ESA.
At Creodias, after 3 quarters of operation, we see the sales funnel, which looks reasonable and quite good. It consists of, its value is made up mostly by bigger and medium projects, but on the other hand, there is a growing stream of smaller customers, I would say automatic customers. This is something that we see as a very big chance that such a stream is going to grow, and such automatic customers will become a more important part. So after 3 quarters, it looks quite good. And if you ask about paying customers, I would say small tens, something like this. So optimistic, or very optimistic after the beginning of the service, but we believe that that this stream of also of smaller business is going to grow.
So first of all, let me point out this technology workshop, and maybe I'm as being a technical person, maybe I'm not the right one to answer the question. So the commercial viability, it's under investigation, let's say. So what I can say is that I know that all our partners are committed to build business on top of the EU funding. But if that's going to be a success in the long run, we will see when we're there.
In our case, we don't have paying customers yet. We do have as many commercial users as public users, so we can already say that there is an interest from the industry on these services. And we can also say that the prices that we're looking at are very competitive globally, and that Thales will be providing these commercial services and the final price list. So it's an ongoing work at the moment.
Thanks a lot for those answers. So the next one are really technical. There's a question from Gilberto to Oldias. How much of the data you offer is analysis ready? There was also another one from Gilberto to Oldias. What catalog service do you provide, such as CSW or Stack? And a third one to Oldias. How can user run Open Data Cube in your environment?
Okay. I take the first. So for on Mundi, so as like the base data, let's say, as I said in my presentation, we have Sentinel-1 data. So I think the GRD data is really available as COGS. If I'm not mistaken, it's all of the GRD data, and SLC is since June last year, something like this. So you have Sentinel-1 data as cloud optimized geodifs. If you want to have Sentinel-2 data as cloud optimized geodifs, help me in convincing the consortium. So I'm a big proponent of trying to convince everybody to have also Sentinel-2 as cloud optimized geodifs. And then higher level data, of course, what I've presented, all the mosaics, it's also cloud optimized geodifs that within as cloud optimized geodifs. Catalog services, we have catalog service for the web and open search. Quite quick. And what was the third question again?
Data Cube.
Open Data Cube. I mean, it's a cloud environment, so I think the easiest way, there is a Docker-based, what is it called? I don't know exactly, but you rent a virtual machine environment and spin it up. I don't think we have a specific open Data Cube service yet.
Okay, so we'll go the other way around. Okay, so answering the first question, I have a little bit different definition of analysis-ready data. So for me, it's data with features already extracted. So we have no. Gilberto, help me here. So
there's an official definition of analysis-ready data that we saw yesterday, which is the analysis-ready data that conforms to the Card4L specification by CEOs. And that's what the community is applying, and that's what you saw. So when I said analysis-ready data is the data that satisfies the specification of Card4L from CEOs that you can download. It's simple as that.
So if I was to say that all the data which is pre-processed is compliant with the definitions, I must say I don't know, but I will check and get back to you with a response because this definition is new for me. But from the perspective of Copernicus analysis-ready data, what we have. We are generating data for Sentinel-2 Level 2A products for whole Europe for 2017 and also the whole production done by ESA, so all the current production. We have Sentinel-1 backscattering and coherence data for selected parts of Europe, namely Denmark and Spain. And also, as I said, we have this whole ordering and automated generation setup that allows to order these products for any area in the world using the base Sentinel-1 products. And also, we have our own EO Data Hub based on Sentinel Hub, which provides a WMS-compatible access to all data it supports, so Sentinel-1 GRD, Sentinel-2, Sentinel-3, Sentinel-5P. So I hope this answers this part of the question. And I will get back to you information because I need to confirm it with my data specialist. So you will receive exactly response to your questions. Next one about the catalog services. Resto is our engine for catalog service, making the open search as the default search standard. However, we have an additional metadata database serving the CSW endpoint, but the primary is open search served by Resto. We actively support development of Resto, adding new features which we need for our specific data sets and our ingestion process. About running the Open Data Cube, I can just confirm what was said. It is a software that can be run on any cloud, provided it has access to raw data. There are injectors for Sentinel data. There are injectors for Lancet data, and every VM in our environment is able to read the uncompressed raw EO products. So you can just set the parameters and build your own Open Data Cube in our environment.
I think to answer from the GEO side regarding the data cubes or analytics platforms, it's as what my previous speakers have mentioned. So it's been considered as a platform service. So you could install any data cube solution and then connect it to the data. So it's theoretically possible. That's not a problem. So everyone could instantiate and do that. Regarding data access and standards, we support various standards. It's Open Search. Our harmonized data access API is Open API compliant, and the metadata is ISO EO metadata, which is returned in that. But we have as well CSW for the catalog search specification. And on the analysis ready data, I would stick out to this because I think it's more towards imagery, and what we access is the data as provided from ESA as distributed. And I don't know if the data distributed like the Sentinel-2 is already qualifying for that, or whether further work needs doing on it.
Okay, so on the analysis-ready data, I'm going to answer the same thing as the others because, as I said earlier, and Gilberto knows I'm not an expert on that topic. On the catalog services, pretty much similar to what has been already said in terms of open search, in terms of OGC standards on WMS, WMTS, etc. On the data cube side, we had, in the course of last year, developed a solution based on the open data cube solution from Geoscience Australia, where we had included GeoRISE algorithms developed by CESBio in the context of an ESA contract. We have had ongoing discussions that since then about taking it to the next step, which involves CESBio, of course, because the algorithms were developed by them. And we are looking into next steps in terms of making that available in the context of different activities that we have. At the same time, there are initiatives that were presented yesterday in the field of data cubes that are launched by ESA. So we're also eager to see how this will fit in, because as was said by the different colleagues on the panel, we have the infrastructure to host open data cube solutions. Thank you.
So very quickly, so regarding the analysis-ready data, so once the data is available in the corresponding hubs, we just make it available into Onda. We do not modify the format of the data. Regarding the discovery catalog, we do have a catalog. It's based on the open data protocols that you can use to search and find and download the data using specific requirements like the area of interest, the time window, the sensor type, the product, etc. And as far as I know, we do not have any specific features for Data Cube, but we do have users that are running time series analysis also on a global scale. And for example, the most recent example I mentioned is the Sentinel-3 Wildfire Atlas prototype developed by the European Space Agency. So I invite you to find more details in our website. Thank you.
Thank you very much. I'm told by the Secretariat that this is it. The time is up. So thank you very much. And this is the moment for the coffee break.